So this is a lovely sort of all-encompassing title of OpenPower Firmware Development, Testing, Community, and Compliance, which is, you know, a topic for hours of discussion. But we'll squeeze it into a small summary that people can find other places to go and look at and talk to people about. So who am I? I'm Stewart. I'm called the Opal Architect at IBM. So I sort of oversee the whole of Opal development, which is the OpenPower abstraction layer. You can email me there. And I work with everyone who works on everything OpenPower, everything sort of Linux and down into user space. So it's kind of a full stack kind of deal. And what is OpenPower Firmware? Well, if you head to GitHub OpenPower, especially the Opie build project, so this is where all of the different firmware components for an OpenPower machine live. And Opie build is what builds them all together into a single firmware image. If you want to know sort of exactly all the different components and what they do, I'm going to give you a YouTube link. Earlier this year in January, I spoke at LinuxConf.au in, where were we? Geelong in Australia. And that video is up there, which is basically an overview of, you know, how you boot an OpenPower system and what goes on. And so that's about 45 minutes of your life that I promise you'll enjoy. The basic boot process is a self-boot engine that starts a core up. We have host boot run. We have OCCs get started. Ski boot, as in Opal, starts, which then loads a Linux system, which runs PettyBoot, which is the bootloader. It lets you choose, I want to boot off a CD, I want to boot off a network, I want to boot off one of my hard drives. And then you have an operating system. So that's the 18-second overview of what took me 45 minutes to explain in that YouTube talk. And you think, wow, that's a lot of firmware code. And it's like, yes, it is. I did a little count with slot count. So we have around 600,000 lines of unique code for OpenPower firmware. And if we go and count all of the rest of the code that's used in that and assembled, it's another 24 million lines of code from elsewhere. So that includes like the Linux kernel that's part of the PettyBoot environment. That, of course, includes the tool chain that we use to build everything, libc that gets run in all these places, all of the user space libraries that PettyBoot uses. And so this is sort of a lot of code. Like it's, you know, we rounded off to 24 million because what's another 600,000 lines of code between friends? A lot of code that gets run just to boot your computer. Right? This is before you are running the operating system that's running the workload you care about. This is everything that's getting to that stage. So I tell friends, it's like, what to do? I work on the code that runs before the screen works, which is the unexciting bit. But you know, if it doesn't come on at the end, you know, people get annoyed. So how do we maintain this code base, right? 24, 25 million lines of code is a lot of code. We have sort of a general philosophy which can be only maintain what we have to, right? Take everything else from upstream, right? So if we're looking at, here's the interface to select what to boot from, we could have written our own interface there, and then we'd have our own way of detecting disks, our own way of talking to PCI, our own way of talking to the network. Turns out that's a lot of work, and we have this thing called Linux that already exists, that already has disk drivers, and already has PCI drivers, and already has a way to display things on a screen. So we could write a simple app that runs on top of Linux using existing libraries that just gives you a menu. So we take everything else from upstream and only maintain what we have to. So if we look at the power-specific parts, we have host boot that makes the processor start to look like a processor, as in you have cores that run and memory that works. You have the OCC, which does like hard thermal limit controls. And then you have Opal, which provides boot and runtime services. So it does things like make PCI happen, and then provides a runtime interface to Linux, the hardware abstraction layer. And then we have these generic parts that we take from elsewhere. PettyBoot is not power specific at all. You can build and run it on your x86 box. That's not a problem. You can build and run it on anything. It's just Linux user space. Opie build, our build infrastructure, is actually just Buildroot, and this came about through the OpenWRT project, and it's basically a way of taking how to build a tool chain, build a Linux kernel, build a bunch of user space, and assemble it into a thing. And so we just do a small extension to that to build the power-specific components and assemble that into the format we need. And then we have, you know, flash manipulation utilities, which are also not power-specific at all. So what we don't maintain. Linux. We don't maintain Linux. We have a large Linux community that does that for us. So we just have people who work on the upstream Linux kernel. User space for PettyBoot. Guess what? We use Buildroot, so everything comes from there. Build tooling, guess what? You get to use Buildroot to construct a tool chain. And a whole thing of the idea of we can contribute things upstream first, so instead of forking everything and maintaining a fork, if we make upstream work for us, then we don't have to maintain a large delta from upstream. And over the history of Opie Build and OpenPower Firmware, we've reduced our delta from upstream to be something that is very, very close. So we run 8 patches on top of upstream Linux 4.4 currently for the Petty boot environment. Like, one of those patches is literally tac-openpower to the end of the version string. There's a very small amount of patches there. Petty boot, of course, is upstream. We use upstream GCC, no custom patches there as well. And so we always push upstream there. And Buildroot as well is now down to about 4 or 5 patches on top of Buildroot. And some of those is actually, most of those are actually backporting existing things from the development version of Buildroot back into a stable version. So we're quite proud of the fact that we're not maintaining large deltas on projects we use. So how do development processes and communities work? This varies a lot by component. So because there's that 600,000 lines of code that's power specific, of course, is several projects worth. And different projects deal with this a bit differently. So hostboot, external sort of contributions to that go through GitHub issues and pull requests. A lot of development is done internally, and this is like well before there is even like a complete simulation of the hardware that will be made in the future. OCC is also a bit internal currently. Skiboot, we're very much on the Linux kernel style of working things. We have a mailing list, and we use patchwork, and the same with Pettyboot. So we have mailing lists and patches there, as well as we'll also do GitHub issues and GitHub pull requests as well will also happen. So there's a bit of variation there between teams, so we can work with people inside IBM and outside IBM, and the way that each team feels comfortable. Opie Build itself, Opie Build brings everything together. So it takes all these firmware components and then assembles, here is the firmware image. The main way that we've developed that is through GitHub issues and pull requests. We also now have a mailing list where discussion happens, and that's a lovely new addition. Or the other way you can do it, of course, is to bug Patrick about something, because I just saw you sit down, so therefore I... There is. We also interact with upstream on all the other projects. So the way we maintain all the other components that go into firmware is, well, let's push it upstream, and then if we have to backport something to our code, we will do that. But the focus is get it upstream. And so the way we develop those is, guess what? The way each of those communities works. So for Linux kernel, it's the Linux kernel mailing list and maintainers. For Buildroot, it's the Buildroot mailing list. For all the toolchain stuff, it's how GCC and libc and everyone work. And how the power-specific user space, so stuff for like getting and setting, like SMT modes and something in there, guess what? We have people who maintain that code base as well, and we work with it that way. So, welcoming newcomers. The best way to get started if you're looking at developing OpenPower Firmware or having a build at it is to probably jump on the mailing list and ask questions. If you get stuck at any point of reading the READMEs and GitHub stuff, guess what? We have a mailing list where you can ask all the questions you want, and hopefully someone will reply nicely to you. So, after we've done this development, how do we then ensure that it works? We have all this code, 24, 25 million lines of it. How do we know if it works? I obviously got the timing wrong, because at some point in the schedule, Sandy's talk was yesterday. It was, in fact, today. But I'm going to blame the international dateline on that rather than anything ever changing. So there's lots of different compliance in an OpenPower system, of course, right? There's hardware versus firmware compliance. One thing is the hardware has to work correctly, which is sort of your base layer. If the hardware doesn't work and isn't compliant to the ISO, you're already in more trouble. For firmware, we want to have sort of an amount of compliance there in testing because, of course, multiple people building hardware systems, we want to make sure that we have the same firmware interfaces. So, for example, the one Ubuntu install CD works on all OpenPower machines. We don't want a situation where you need a per system install CD. That would be awful and annoying. And that's just for me, let alone end users. We also want to make sure, of course, that between each revision of firmware, we don't have regressions. We also want to make sure that we have a consistent boot interface so that your currently installed operating system will continue to boot when you update the firmware. ... news coming on an exerciser. See the previous talk 15 minutes ago. We have HTX out there to do sort of more intense exercising of the system as a whole. And that exercises, part of the firmware interfaces and part of the Linux system as well. But that is, of course, sort of a different thing than sort of functionally testing parts of the firmware as well. So how do we test firmware? Well, guess what? We have a thing called Opie test framework. This is a project to sort of have one overarching sort of test runner to run a whole bunch of compliance and verification tests for OpenPower firmware. And this is very much a work in progress, right? So this is trying to take a bunch of existing testing that was happening inside IBM on IBM Power firmware stuff and refocusing that whole effort to have, here is an open source project that anyone can go and run, and then we can have it based for different users. So we can have things like, it could perhaps run HTX if you're doing a system test, as in like, is my brand new OpenPower system that I've just manufactured going to work correctly? We could have a job there to say, I have a new firmware revision. Is the firmware part working correctly? Or I've updated the BMC. Is all the BMC functionality working correctly? And the way that talks to the host processor. We also have internal tests. There's a lot of existing testing that keeps happening inside IBM. And the idea is that we move all of that as open as possible. There is also other open source test suites. So we have stuff that's sort of above the firmware level. There are, of course, test suites to test like KVM functionality, which tests, can you still start virtual machines? There's the Linux test project that very much focuses on testing Linux itself. And so we have these other test suites that we can run as part of like the whole system of verifying it. But the idea behind having an OP test framework project there on GitHub is to collate what we care about from a firmware point of view. So that is a lovely project you should come and contribute to, of course. How do we test and do Opal things? We have documentation, which are lovely text files on a directory, which is lovely because you can read that on a terminal and in Emacs, which is the one true editor in case there's any VI users in the room. Yeah, I have the microphone, therefore Emacs wins. We also have the boot interface. So PettyBoot itself has its own test suite. So for testing things like, can we still boot off a CD-ROM, for example? There is a PettyBoot test suite that's just launches a whole bunch of virtual machines with a whole bunch of configured disks and a whole bunch of different OSs and runs through automated tests. So that's testing that PettyBoot component. So we have a mixture of sort of individual unit tests, and then we can test the whole system as itself as well, which is kind of useful. So what about now and future? We have just... Am I preempting anyone announcing OpenPower Ready? Yes, good. OpenPower Ready is a new definition that's out there that is basically a self-assurance thing of saying my system conforms to some basic set of requirements to be called an OpenPower machine. And that's part of sort of our current way of saying, if you do this and don't do that, you'll be compatible with other OpenPower systems. In the future, we hope to have a very much more solid and easy to run, for anyone in the room that wants to run it against their machine, a conformance and compliance test suite where you go, does this machine I'm currently sitting at as a user conform to OpenPower standards? And it will come back and run for, however many minutes it is and say, yes, it does. Or, no, it doesn't. Your changes to your firmware have made the system no longer valid. And that's part of the work in progress. We have all those existing test suites I talked about that we run internally and run externally as well that may or may not be easy to hard to run. And our aim is to have that being an easy compliance suite that becomes a compliance document, which is run this command, and if it passes, you're okay, is like the ideal world. And we'll see how close we get to that. And so part of that, of course, for compliance is a test suite. And a part of that is a compliance statement saying, I have and have not done these specific things. Cool. We have, I believe, 44 seconds for questions, if there's anything of that. Or feel free to come up and ask me questions, or shoot me email, or contact any one of our wonderful IBM firmware developers around the room who I could probably cajole to raise their hands and be dobbed into answering questions. So